Here's how I swapped out the old Dometic heater in my dad's vintage 1980s Fireball RV for a new one by Vevor. I removed the old heater off camera. There was a significant wood rot due to the old heater leaking. Actually, this is not uncommon in the right rear of these vehicles due to moisture from the heaters and leaks. Here's the front of the old heater. The top PEX line is actually the hot water line, and it's stamped hot into the case. The new ports were in slightly different locations, so rather than replumb, I used some flexible faucet hoses.
Okay.
I don't want to over tighten this because actually you can damage these compression if you over tighten them. So see now you can use the yellow gas tape for water because it's a higher grade, but you can't use the water grade tape for gas. You'll need to align these holes with the 2 pins inside the thermostat port. Push it in and turn the sleeve clockwise until snug.
There's no bubbles, then it's holding. That's how most people do it. So now, and I've done multiple gas appliance installations. So I know all this stuff.
Okay, this is going to have to be trimmed out right here before we can put the door on.
Right.
Then I snugged up all the hoses and connections with a crescent wrench. The old propane tank is located under the passenger side, but it's very rusted and no longer able to be used. So the new one was replumbed and it only hooks up to the stove and heater using this 3-way joint. The top line goes to the stove and the lower one goes to the heater in the rear. Just a note, never use Teflon tape on these flared style propane fittings. The tape will prevent the flare from seating properly and it will leak gas, as you can see from the bubbles here. There were 3 wires on the old heater, however there are only 2 on the new one. This wiring diagram on the back of the old heater shows that the red was power, which is expected. The yellow here is the heater ground. It's not unusual for brown or yellow to be used as a ground color in addition to black. I actually had no idea what the blue one was. According to Google Gemini, it was the heater fault light. This makes sense as many types of sensors and automotive idiot lights are designed to ground themselves when there is a problem. So initially I did try to wire the power to power and ground to ground, but I couldn't get the heater to turn on. So I then tested the wiring with the power probe. It's hard to see, but the red power line actually shows 0 volts. Both the yellow ground and the blue ground caused a beep and a green light, which means they were good grounds. So the next order of business was to check the power distribution box. I first had to disconnect shore power, disconnect battery negative, and cover the solar panel so that it would not send voltage to the distribution box while I was working on it. All the fuses inside appeared to be okay. And to be perfectly honest, I really didn't want to do any major work on that crusty old circuit box that needs to be replaced anyway. So I decided to just run a fused line from the positive bus bar to the heater. After soldering all the connections, I wire nutted the power to power and capped all the grounds together, but the thermostat would not turn on. At this point, because I don't do a lot of wiring, I wondered if I had made a bad soldering connection, so I checked power across every point in the line with a micrometer and I got continuity. I even used the power probe to send power through the line and I measured 12 volts. So to rule out a problem with the heater, I used jumper cables directly from battery positive to a fuse and then to the power side of the heater. And sure enough, the heater turned on. So here's where I needed to enlist AI. And I will admit that both Google Gemini and ChatGPT have been greatly helpful to me in many of my automotive projects. It is not advisable to wire copper to aluminum, according to Google Gemini. Firstly, aluminum is a notorious fire hazard. Secondly, there are different expansion rates of copper compared to aluminum, and this can cause the different wires to pull away from each other. And thirdly, there's a galvanic response which can cause like rust and corrosion and like sludge buildup between different types of metals. So we went to Lowe's and got this Alumicon connector. I was pleased to find out it comes preloaded with dielectric grease, which I accidentally got on my fingers while fumbling with the wires. I made the connection and tried again, but there was still no power. So now I was stumped, and as a last resort, I tested the power to the bus bar. For some reason, the terminal which I originally hooked up my new fused line was not getting power. So I put on a larger terminal and connected the new line directly to battery positive. And thankfully, the thermostat turned on. It did take maybe 30 to 40 seconds, but I did end up getting hot water. So now my dad can focus on the carpentry and I can focus on getting a better bus bar later. So although Gemini did give me some really important safety information, it did end up being the human, me, who figured out the problem in the long run.